definition of metadata?
It's data about the data. So like if you are recording information about say fertilizer 1 and fertilizer 2 are two values you are using here. Now how do the user know what's fertilizer 1? So there is a whole description of fertilizer 1, this brand, this concentration, these elements.
Okay.
So all that details about the data is called metadata.
Yeah.
Okay. So that's a little like what we were talking about, where we would have a separate file that would contain that information.
But one thing,
Yeah, but I mean, at this level where we have only 2 fertilizers, then we'll probably have just a simple metadata file. But in case we have like 10 different fertilizers, or if they have different concentration, so what she's suggesting is that you update the main table, and it would update the related table automatically, which would be so amazing.
That sounds a little scary too, though.
Really?
Well, that's why, whenever you make the changes, save it and just kind of compare the old to the new,
And so
query
you
out, query out and make sure things are updated properly.
I mean, another thing with this too is like for the Bonanza Creek, maybe, for each of your creeks, maybe there's some other information that goes along with it, like lat long coordinates or, I don't know, temperature on that day. And that's something that you don't really need to have in the data where you collect, your greenness. You don't need to have a column in there repeated with the attributes specific to your Bonanza Creek. It could just be in a separate data, and if you need to get it, then you can just go and look, at that table. It won't be repeated, a column repeated in your analysis, basically what you're measuring, the length, width, and greenness. So it might make more sense as I go through this. I was just trying to get you guys to think and see what, maybe you already know everything.
Well, I really think we're all blabbed.
I was just thinking, my
Bad files.
husband was trying to explain access to me, and he was saying the same words that were just coming out of your mouth, and I was just completely confused. But I think it's really hard to understand without getting an example, and I still don't quite understand how it works, but I understand a little better.
Yeah, I have some examples, hopefully.
Okay.
I use this book. I find that that's a really helpful book to, has lots of good stuff in it, so you can take a look at that if you want to. I'm going to write it down there. And yeah, I used 2003, so I'm not up on 2007. But, okay. So what to look for in a database? I kind of hinted on this, that it divides your information into subject-based tables to reduce the redundancy of the data. So if, like I had shown, if there was, some information about, each of the different creeks that you shouldn't really have that then in your greenness measurements, because it really doesn't have anything to do with greenness. It's a totally different subject. It's related to the creek, so that's where it should stay. If it's a relationship database, it provides the information required to join the information into tables together as needed. So you have all this information into different tables, but you can use queries to query it into one table. Also, I'll get into it later, but you can also use forms where you enter data into multiple tables at the same time in one spot. It should help support and ensure the accuracy and integrity of your information. When you make relationships, you can put rules on it so that things can't be deleted that should not be deleted. And I'll show you some examples of that as I go through here. It accommodates your data processing and your reporting needs. Say maybe you have to do a lot of reports. In Access, you can automatically generate reports. You can save that and make quick reports. Also, your data processing, that would kind of be like file size and stuff like that. And like I mentioned before, thorough documentation. If possible, try get a hold of metadata that explains what the database is, and I did go through what metadata is and kind of some rules regarding it, what you should include.
Some common mistakes. I'm going to go through a list of common mistakes and then kind of go through each one. So just in general, poor design and or planning, right from the start. Ignoring what's called normalization, or a table that holds everything, like I just mentioned, a flat file, so just having one Excel spreadsheet that holds all your data. Ignoring normalization. Normalization is the process that you go through to reduce data redundancy, and go through that. Poor naming, lack of documentation, failing to define no values, lack or poor identity columns, and identity columns are like your unique ID. Not using referential integrity or rules to protect the integrity of the database. That's how I was talking before about you can't delete this article or this record if there is another record in another table that's attached to it. So like say you have an interviewee and you try to go and delete it, but there's subsequent interviews that the person has done. You can set it up so there's no way that you can do that. And yeah, if you don't know where you're going, any road will take you there. Build any database you want.
I feel like I should have had this talk years ago.
And these are just some cartoons, just about design and planning. Obviously, things didn't go as they wanted it to go.
There is a museum that was built in Glasgow, Scotland, and the architect, when he came to come see the it's the Huntington Museum in Glasgow, he came and it was built in the wrong direction. And he was so upset he threw himself off the top and committed suicide.
Really?
Yeah, because it was...
The wood center is supposed to be oriented differently.
You
The
know,
wood center, have you ever noticed those
Oh, really?
big glass windows all facing west into the trees? Like all those big glass windows, the whole thing is supposed to be 90 degrees. Front 90 degrees so that the sun hits those big glass windows.
and I've heard this for the
Huge
Univ
solar
building too, that
absorption.
it got flipped by mistake. So
Well,
the
all the
south
windows
facing
are-
is north facing.
Did somebody jump off them?
No, they were just
Then it
formed
doesn't
by
matter.
us. No.
No, design and planning.
Yeah. And I mean, you guys kind of already got to it. I mean, it's basically like, you're an architect, designing a building. And you really save yourself a lot of time in the end if you sit down and seriously think about this. I find it helpful to sketch out, how your database is going to work. This is an example of one that I put together, where these are the bunkhouse files, or the moose surveys, just the paper, and so I was just trying to sketch out what my relationships would be. Like, that's called a big diff number. It's just the unique ID number for a specific moose survey. This is the actual survey data with the numbers of moose. And these are kind of like the paper maps. And then these would be like your spatial maps, the maps that actually got digitized. And just looking at how you can have, in a year, you can have multiple different surveys. So you can have many to many, whereas where the primary keys in each of them have different separate tables. It's a unique relationship. So I find drawing things out helps. Planning and design, things to think about is, what type of data do you have? Spatial data, photos, audio, I know Access can deal with photos, whereas like say Excel, it's really hard to have a photo in Excel. What type of data do you have? I'm not too familiar with audio data. What is the maximum size of the database? Kind of looking at the number of rows and the number of columns. As you can see, SAS can accommodate many more rows than what Excel can.